Welcome back, and I've got a really fun experiment for you today. It's a home experiment, so when you get back you can try it yourselves. What we're going to look at is what causes gases to come out of solution in liquids. So the first thing we need is a liquid with a lot of gas dissolved in it. So I've got a bottle of mineral water here and I've not yet opened it. And what we're going to do is just take the label off it. And if we remove the label, we'll be able to see what's going on inside the liquid rather better. So I've removed the label completely. So we've got a clear bottle of mineral water. And what I've got in my lunchbox here, this is a periodic table lunchbox, everybody should have one of those, is a whole load of raisins. I've driven my partner absolutely mad experimenting with raisins of different sizes and types, but what I've found is that these seem to work best. So I've got raisins that are quite small and I've let them dry out a little bit, and we'll see what happens when we open the bottle and drop a raisin into it. Right, so here goes. Let's open the bottle gently. This one's been a bit shaken up, so I've got to be a little bit careful. And you'll see some bubbles come out of solution straight away. But of course, there's more carbon dioxide dissolved in here than has just come out. And what we'll do now is just drop a raisin into the top. And what I'd like you to do is watch what happens to that raisin. At the moment, it's floating on the top. And we'll knock a few bubbles off it, and down it goes, and back up it goes again. So something rather strange is happening here. So let's do that again. In goes the raisin, and you'll see it fall down almost to the bottom of the bottle, and on its surface it collects bubbles, and there we go, up it goes again. Down it goes, back up again, and off it goes down again. And you have to experiment a bit. I've spent a bit of time playing with different strengths of mineral water that's quite full of gas, mineral water that's getting a bit flat. And I've used different size raisins, but you get a really interesting thing happening. You get the raisin picking up bubbles, rising to the top, and then sinking back down again and repeating the process. So what I'd like you to do is try this at home and experiment with different mineral waters, but particularly different sizes of raisin. So, time for a bit of an explanation, but I'll just stick a few more raisins in just for fun. Drop one on the floor there. So, what's happening here is we've got carbon dioxide dissolved in the water, and it stayed in the water with a lid on because it was under pressure. But now we've opened it to the atmosphere and got atmospheric pressure at the top. The carbon dioxide is trying to come out as a gas out of the solution that it was in the water. But it needs a surface to form a bubble on. You need a surface for the bubble to sort of appear. And so that's why you don't normally get bubbles appearing just in the centre of the liquid. But if you throw a raisin in, the raisin's got a rough surface, and so there's places, we call them nucleation sites, for the gas to come out of solution and form into bubbles. But of course there's something else that's going on as well, because you see the raisins going up and down in the liquid. When they fall in, the bubbles form on them and the bubbles get larger and larger until we reach a point where the buoyancy caused by the bubbles is greater than the weight of the raisin that we've thrown in, so up it goes. And there's a bit more complicated physics there too, because as it goes up, the bubbles get slightly larger as the pressure gets lower. When it reaches the top, the bubbles break out the surface, break off the raisin, and now its weight is not counterbalanced by the buoyancy from the gas bubbles, so down it goes again. Picks up more bubbles of carbon dioxide and up to the top. And this will repeat for quite a while, so it's quite fun to watch. So do try this experiment at home. It's great fun. You'll have to change some of the variables as you go along. Different sized raisins, maybe ones that are dry, those that are a little bit damper. mineral water that's really bubbly and mineral water that's not very bubbly. But when you get it right, it'll actually keep going of its own accord for a while. I'm having to shake it a bit here to get the bubbles to break off the raisins. Anyway, it's a great fun experiment. It shows buoyancy effects really, really well. So I hope you enjoyed that, and I look forward to seeing you again next time.